Okay, class, we have calculated U and V. U is the dispersion in the width of the crack, and V is the dispersion in the length of the crack. Okay? And we need to calculate the aspect ratio scale, K equals to 0.5, and you can select which curve you need to use. Then in the y-axis, you see, in the y-axis, you have V by L, and in the x-axis, you have U by B. So since we have calculated this value, just calculate V by L and U by B. V by L is V 3.7. V by L V 3.78 divided by L, length of the slab 5 meters. It is coming as 0.752. This is in the y-axis we need to see. U by B equal to U is 1.01, whereas width of the slab is 2.5 meters, and this is coming as 0.404. And we need to refer to the figures curve now. Okay, so I will show you figures curve. Okay, so here in the figures curve we need to see for k equal to 0.5. So this is one curve and this is another curve. From this curve we will find the coefficient m1, and from this curve we will find the coefficient m2. Okay, so what is the value of v by L? The value of v by L is 0.752 0.752. Okay, so 0.752 will be between 0.6 and 0.8. Okay, it will be at this point. And what is the value of u by b? The value of u by b is 0.404. It will be here. So you need to draw the perpendicular line from the x-axis and the line from the y-axis corresponding to those values. And something near 9, those curve will be interacting. So at 9 curve, you'll be getting the interaction. Okay. Okay. So no. So we are getting M1 into 100 equal to 9, and similarly M2 we are getting M2 into 100 equal to 0.95. So these two values you are getting from the curve for V by L value, for U by V value. So M1 equal to 9 into 10 to the power minus 2. Similarly, M2 equal to 0.95 into 10 to the power minus. Okay. So now we can calculate, we can use the formula and we can calculate MB and ML value. MB equal to W M1 plus mu M2. So MB equal to 350 kilonewton into M1 is 0.09 plus mu is 0.15 and M2 is 0.0095. So MB, you are getting MB equal to 32 kilonewton meter. Similarly, ML, bending moment along the longest span. ML equal to W bracket M2 plus mu M1. W is 350 kilonewton. M2 is 0.0095 plus M1 is 0.09 into mu. Okay, so ML you are getting it as 8.05 kilonewton meter. Okay, so you got the value of MB and ML. So since it is a live load, we also have to multiply the impact factor. So impact factor for for 5 meter span, the impact factor is 25%. So in the previous lecture, I told you how to find the impact factor. So refer that. So here the impact factor will be 25%. So it is given in IICS 2017. There is a chapter for the impact factor in that IIC course. Okay. So NB equal to 32 into impact factor into continuity factor. So the interior panel is continuous. You also have to multiply the continuity factor. The continuity factor is 0.8 here for the continuous. The slab is continuous. The bending moment factor will be the continuity factor will be 0.8. 32 into impact factor is 1.25 into continuity factor is 0.8. One second. बताओ अंदर आओ क्या हो आप अपना है ना रोल नंबर और कुछ लिख के दो मुझे और क्या इश्यू था वो लिख के दो पेपर में मैं देखता हूँ Okay, so bending moment is 32 into impact factor is 1.25. You have to increase 25%. So for that you have to multiply 1.25 and the continuity factor is 0.8. So when you do this calculation, again you are getting 32. Similarly, in the ML also you have to apply the impact factor and the continuity factor, and the value of ML will be 8.05 kilonewton meter. Okay. So we have gotten the bending moment due to live load. We have gotten the bending moment due to live load. Now we will see bending moment due to dead load. Bending moment due to dead load. No, for the dead load, we do not have to multiply impact factor. We do not have to consider the impact factor. And the nature of the dead load is UDL. It is not point load. So we need to refer that curve of figures curve which has UDL component. Okay. So here the load is uniform. To find the bending moment, first we need to find the dead load of the slab and dead load of the bearing force. Dead load, dead weight of the slab, dead weight of the slab equal to 0.25 into 25. 25 is the density of the concrete and 0.25 meter is the depth of the slab. This is equal to 6.25. And then you have dead weight of the bearing force. Dead weight of the bearing force, that is WC, which is equal to 0.08 into 22. And this is coming as 1.76. Okay. So the total dead load is total dead load equal to 8.01 kilonewton per meter square. Okay. So once you have gotten the total dead load, now you can find the bending moment due to dead load. Again, the K is 0.5. So when you are referring to the dead load, when you're finding the bending moment of dead load, you have to write the value of K and also the value of 1 by K. Okay. You have to get the value of K and you also have to write the value of 1 by K. 1 by K will be 2. Okay. So, okay, U by B and V by L. So here we do not have the concentrated load. Since we do not have the concentrated load, the U value will be equal to B value and V value will be equal to L value. Okay. So U by B equal to 2.5, 2.5, you're getting 1. Similarly, V by L, will be equal to L because it is, uniformly distributed load. 5 by 5 equal to 1. Okay. As the panel is loaded with uniformly distributed load, U by V and V by L will be equal to 1. Okay. So I will tell you about the curve, how the curve will be for the UDL. The curve will be like this. You have M1 and M2, M1 or M2 from the y-axis. Directly you are getting M1 or M2 from the y-axis. In the x-axis, you have the value of K or 1 by K. So K is for M1 and 1 by K is for M2. Okay. So I will show you the curve. I'll show you the curve for the dead load. Okay, this curve you need to refer. Here they have written the moment coefficient for slab completely loaded with a UDL. So the dead load, the nature of the dead load is UDL, and you need to refer this curve to find the M1 or M2. So in the directly from the y-axis, you are getting the value of M1 or M2, and in the x-axis, they have given the value of K or 1 by K. And here they have mentioned M1 for K and M2 for 1 by K. So the K value is K value is 0.5. For 0.5, you see what will be M1, and for 1 by K is 2, and for 2 values, you have to see what is the value of M2 from the y-axis. Okay, so I will write the value directly. I will write the value. Okay, M1 you are getting it as M1 you are getting it as M1 equal to 0.048 and N2 equal to 0.009. 0.009. Okay. Okay. The formula is NV equal to W into M1 plus mu M2. And what is W? W is the concentrated load. And here we have the UDL. So what UDL we have gotten? The UDL that we have gotten is the total load, that is 8.01 kilonewton per meter square. So 8.01 kilonewton per meter square cannot be taken here because it is concentrated load. So UDL has to be converted into concentrated load. So how to convert that? You see, the UDL is 8.01 kilonewton per meter square. So when you multiply the area of the slab to this UDL, you are getting in kilonewton. Okay, 8.01, and the area of the slab is 5 into 2.5. So you are getting it as 100.125 kilonewton. So you got the value of W, we can directly substitute here. MB equal to 100.125 into M1 is 0.048 plus mu is 1.15 and M2 is 0.009 into continuity factor. So you cannot, multiply the impact factor. You have to multiply the continuity factor because impact factor is related to the live load. It is not related to the dead load. Okay. So multiply continuity factor and directly you get the value of NB. NB is equal to 3.95 kilonewton meter. And similarly, we can find the value of ML. ML equal to 100 into 1.125 into M2 0.009 plus 0.15, that is mu, into M1. M1 is 0.48 into 0.8 So ml you are getting it as 1.3 kilonewton meter. So what we have seen in this text session, we have seen the analysis of the interior panel. We have calculated the bending moment due to the high load. We have also calculated due to bending moment due to dead load. Okay, in the next class, we will see the calculation of the shear force due to live load and the calculation of the dead load, sorry, calculation of the shear force due to dead load. We will see that in the next class. Okay, thank you very much for the joining.